Hi, my name is Sabir Desai, and in this video I'm going to teach you how to predict the product of a reduction reaction.
In earlier videos, you learned that while a reduction reaction can be identified by a reduction in oxidation number and a gain of electrons, you can also look for a loss of bonds to oxygen or gain in bonds to hydrogen. So when you predict the product of a reduction reaction, you can use this knowledge to identify where reduction is going to occur. Look for a carbon-carbon double bond or triple bond because hydrogens can be added to these bonds in the conversion to an alkane. Additionally, in a reduction, you're looking for a decrease in the bonds to oxygen, so carbons bonded to oxygens will likely occur there. Lithium aluminum hydride is a strong reducing agent, mentioned in a previous video. In the mechanism, two equivalents of hydrogen are able to detach from this reducing agent and are added to esters and acids. Let's use a carboxylic acid as an example. The resulting molecule still contains a carbon and an R group, but there's an overall decrease in the number of bonds to oxygen because when the alcohol group is kicked off, one hydrogen is picked up by the carbonyl oxygen, and now that the carbon is only bonded to two entities, the two hydrogens can be added by lithium aluminum hydride here. So while lithium aluminum hydride is able to reduce esters and acids to alcohols, it can also reduce aldehydes and ketones by donating one of the two hydrogens. Additionally, it can reduce amides to amines. Sodium borohydride is considered a weak reducing agent, and unlike lithium aluminum hydride, can only reduce aldehydes and ketones, like this, to alcohols. Again, the mechanism starts off the same, where the carbonyl oxygen picks up a hydrogen, resulting in three entities attached to carbon, and then NABH4 is able to add a hydrogen to create a fourth bond to carbon. So why can a strong reducing agent donate two hydrogens, but a weak only one? It's because boron is more electronegative than lithium, and that boron is able to keep a tighter hold on its hydrogens. Since the boron is holding onto the hydrogens, it's unable to donate two like lithium would. Another way to reduce molecules is through hydrogenation. This is the addition of H2, or two hydrogen atoms, to a carbon-carbon double or triple bond, again increasing the number of bonds a reactant has to hydrogen. Catalysts like palladium, nickel, and platinum allow for the reaction to occur. Let's apply this knowledge to a question. This question asks you to predict the product in a reduction reaction, and each question includes a reagent that is a reducing agent. Let's start with A. The central carbon in the reactant, acetic acid, has three bonds to oxygen, two coming from the double bond to oxygen, and one from the alcohol. The other carbon on the left has no bonds to oxygen, so it must be the central carbon that is able to be reduced. The reducing agent is lithium aluminum hydride, which is a strong reducing agent and is able to reduce acids to alcohols through the addition of two hydrogens. So the resulting molecule will still have a central carbon bonded to the methyl and an OH, which allows for the addition of two hydrogens to the product. Moving on to B, notice the reagent is H2 with a metal catalyst. This should indicate the addition of two hydrogens to a double or triple bond. But it looks like there are two double bonds, the carbon-oxygen and the carbon-carbon double bond. So where will the hydrogens be added? H2, with the lead-carbon catalyst, acts specifically on pi bonds to make an unsaturated alkane, and will not reduce carbonyls, so the resulting molecule would have the hydrogens added to each carbon in the double bond, resulting in 2-butanone. Finally, C, which uses sodium borohydride as the reagent. This carbon on the ester has three bonds to oxygen and would be a possible site of reduction. Although keep in mind that NABH4 is a weak reducing agent and only able to reduce aldehydes and ketones to alcohols. Therefore, it's not able to reduce this ester and no reaction would occur. You should now feel comfortable with predicting the product of reduction reactions. Make sure to follow up with practice to master the concept.